So while we're on this relatively simple graph, I want to just begin to show you that you can look at things in 2D. So if you press this button here, then we get the same graph here. Now, there's a slightly different way that we interact with things here, so that we interact things by moving left and right, yep, with the left button, and then the right button is zoom. Now, it's a reality. I was at a graph meeting in Japan a couple of weeks ago. I spent 2 hours trying to tell someone why we did things in 3D. There's a remarkable reluctance for people to accept 3D as a good way of visualizing things. If you feel like that, do it in 2D. I'm sure you'll spend most of your life in 3D. It's a nicer interaction. Okay, but what it does allow me to do is show you one other thing here. So one thing you can do in 2D which you can't do in 3D is you can move nodes. So I can click on a node here and decide that it should be there. Okay, so I'm going to come on to another point now, which is about layout. So graphs, it's a visual medium, okay? And what you're trying to do is take all this information and display it in a way that you can visually interpret, okay? And there is a huge amount of work in graph theory about laying out a graph. So if I wanted to look at this graph and understand the structure here, I could think about pulling these here, pulling out the relationships. Generally, we don't want to have crossing lines. Okay, where would I best put that one? Maybe that one there. Oh, maybe that's pulled up there. So, you know, it's the same graph. The layout is just different. Okay, so layout is almost an aesthetic thing. Okay, it's about making it visible to understand the structure. And so for a lot of people who work with small graphs, there's a lot of interest in making the layout readable, okay, human readable. Now, what you notice is that what we put into the tool was just 2 columns of data. But all of these guys have a place in, you know, when you look at it, you haven't thought about it, but what you've just done is used an algorithm called a layout algorithm to place things in their proper place. Now, I'm just going to show you this layout algorithm. You don't see it when you load data normally, but this is a way that we can actually show what a layout algorithm does. I might have a better way of showing it to you in a wee while, but you see what just happened then? So I'll make it actually bigger. So layout. So we have a layout tab here. So what I'm going to do here, so what a layout algorithm does, so we use what is called force embedded algorithms, okay? So these treat nodes and edges as springs. So you have a spring that basically pulls things together, but you also have a repulsion force that forces them apart. And what a layout algorithm doing is trying to find the energy or the least stress, the way that you can position things with the edges are not forced together and the repulsion force is there. So you can actually think about these things as stress graphs, and what you're trying to do is minimize the stress. So I'm going to just make that sort of slightly higher. So if I make this value here, I'm making the repulsion value higher in your graphs, and so you're forcing things further apart. And I'm going to make this 200 so that you can see what's happening. Okay, well, there's a bit more we can do on graphs. Okay, right, so now I'm going to force it apart, and you should hopefully see it here. Okay, what it's doing there is trying to force things apart and move things across. Okay, so in 2D you can do the same graph, it's the same graph, but you can basically move it over in that way. And now when you look at your graph in 3D, it's now in 2D. Okay, yeah. So again, we can just press that again and we can expand it out. So we have 2 different algorithms working within the tool, one that works in 3D and one that works in 2D. They're kind of same algorithm, but actually in 3D you have an extra dimension that you can put things in. You have a Z value, okay? So when you go from 3D to 2D, all you do is take off the Z value. All right, we've probably done enough of this graph now. But you get the idea that you can kind of pull things in, you can show edge weights. Now I'm going to move this back again. So making...
Could you go over the K? So the K value is the force of attraction and repulsion between. Okay.
So basically, if you increase the K value, what you're doing is making the repulsive force between nodes higher, so that nodes will separate further from each other. Okay. Very basic, but probably about as level I understand it. So there is one more format here. You probably won't use it much, but I'll show it you anyway. There's an idea that an edge actually has a meaning as well as a weight. Okay, so that you could, let's say, if you were plotting a protein interaction network, have the fact that different nodes, different edges meant were different things. They implemented that something was a phosphorylation or a binding event or the like. So if we put this in, this is called, again, just a text file. So if the tool receives a text file, it just kind of looks for 1, 2, 3, or 4 columns and will interpret as such. We put this guy in. So this is exactly the same graph, but now what you can see it's done is it's put a little pseudo node. So that node is representing the type of edge that is, because we can't do it in any other way at the moment. So we don't have much control over edge colors in that sense, and so a way that we can actually infer what that edge might mean is to put a little node in it. I don't think you're going to use this. I'm just showing you.
If you do, is there a way of putting up a legend that shows you?
Yeah. So well, if you did, because it's kind of just treated as a node. So if you show all node names again, you can see. So you see what it's done. There are 10 ubiquitinizations in there. It's given them all an individual number. Okay, so it didn't have a number when it went in. It has to name them to discern them as being different. Okay. Right. Are we all happy so far? Good. Right, are we ready to go to something slightly bigger? And some gene expression data?
Yeah.
Yeah, let's hit it.